Hello everyone, this is your Weather on Fly Outlook and discussion for Saturday, April 12, 2025. Update concerning convective outlook days 1 to 3. For today, there is a marginal risk of severe thunderstorms across parts of southeast Montana and northern Wyoming. A shortwave mid-level trough will move eastward across the Pacific Northwest today, as an associated 50 to 60 knot jet streak translates eastward into the northern Rockies. Ahead of the trough, a surface low will deepen across eastern Wyoming, which will increase low-level convergence across parts of the northern high plains. Surface dew points in the 40s will contribute to weak destabilization. As surface temperatures warm, thunderstorm development is first expected in the Bighorn Mountains during the early afternoon, with these storms moving eastward into the lower elevations of southeast Montana. Additional storms will likely develop in northern Wyoming, closer to the mid-level speed max, and the environment should support a threat for severe wind gusts within the stronger downdrafts, with the greatest severe threat occurring in the late afternoon and early evening. For Sunday, isolated, elevated thunderstorms are expected to be the predominant convective scenario. An amplifying shortwave trough will move east across northern portions of the Great Plains and upper Midwest. This will yield deepening of a surface cyclone from the Central Plains to Lake Superior. Despite this amplification, poor quality boundary layer moisture return relative to a stout elevated mix layer appears likely to inhibit surface-based storm development through the period. Thin, uncapped buoyancy will probably be relegated to parcels around the 700 millibar layer. This will expand east during the day from the upper Midwest into the Great Lakes, where small hail is possible, mainly across the upper Mississippi Valley, where fast flow will exist in the cloud-bearing layer. Isolated thunderstorms are possible in Colorado by late afternoon Sunday within a post-frontal environment characterized by limited low-level moisture and meager buoyancy. Very isolated thunderstorms may develop Sunday night into Monday morning with eastward extent across Kansas to Missouri. Scant elevated buoyancy may develop as 700 millibar layer frontogenesis strengthens within a highly diffluent upper-level flow regime, atop an increasingly post-frontal stable surface. For Monday, there is a slight risk of severe thunderstorms in the upper Ohio Valley and central Appalachians. A shortwave trough will further amplify over the upper Great Lakes eastward towards the Ottawa Valley through early Tuesday. In its wake, a separate shortwave impulse and attendant mid-level jetlet will dive southeast across the northern Great Plains towards the lower Ohio Valley. This will yield a broadening upper trough from the north-central into the eastern U.S. At the surface, the lead wave will foster a near 990 millibar cyclone tracking from Lake Superior to the Ontario and Quebec border. A cold front will arc south across the lower Great Lakes and then southwestward through the mid-south by late Monday. Guidance is reasonably consistent that at least isolated thunderstorms should develop in the early to mid-afternoon across the central Ohio Valley vicinity as mid-level height falls overspread the confined but destabilizing warm and moist sector. With already strong 700 to 500 millibar southwesterly strengthening further, fast-moving and highly sheared convection is anticipated. Despite veered surface winds, low-level hodograph curvature should be moderately enlarged. This setup may yield a few supercells that consolidate into a cluster spreading east across the central Appalachians. A couple tornadoes and damaging winds appear to be the primary hazards. East of the higher terrain, remnant steep low-level lapse rates may support a threat for isolated damaging gusts given the strong wind fields, before convection becomes increasingly elevated Monday night. Be sure to share, like and subscribe for the latest Storm Prediction Center outlooks.